Welcome back to a lecture series on digital image processing. On the talk of the title today, unsupervised classification. In the last class, we have seen the supervised classification. Classification is a technique of grouping the data, of the grouping the pixel values together, and then classify with respect to the similar values, and then accordingly the features are also classified. So in a study area, we will let to know how much of area which covers in a single particular domain, like that a water body, how much area it covers, or a vegetation, how much area it covers. So that is the actual picture work of supervised classification or unsupervised classification. There are two major classifications, of which the supervised, it is a human intervention is involved. I mean, a trainer is giving training to the computer to classify the examples, maybe from the color to the pixel value classification, or pixel value classification to the color. He can do both. Suppose if he is doing from the pixel value to the foreground, he must have an idea that otherwise he has to collect some field data through spectroradiometer. By using that, he has to classify the image. It is like that, by giving training, fine tuning, and then the other one, suppose if I am so urgent, I have to finish the classification quickly in any disaster situation like heavy flood, or any situations, bigger situations like landslides or earthquake. I am interested to see how much of area is damaged. So under such circumstances, we have to depend the system. Instead of giving training, it will take very lot of time. That depends upon the area of investigation. Disaster covers normally in a bigger domain. By the time if you do a slow work for about months together, it will not be able to solve, or you cannot give any direction to the end user or the administrator to take up your technology to the society, to the people. So these circumstances, we need to depend, and we have to ask the system to classify on their own. So set of mathematical algorithms is designed in such a way to group together, and then automatically system will do. Only thing what you have to do, you have to tell how many classes you want. The system, suppose if your class pixel varies between 0 and 100, you can ask your system to divide by 10 divisions. Immediately your system will do 0 to 10 one sector, 10 to 20 another sector, 30, 40, 50, and then so on. So you will be getting 10 different combinations of your pixel value differences, and then you will get the end result of 10 divisions of classification. Now this is the basic concept of unsupervised classification. Let us see what exactly it is and what is the advantage and disadvantage. This is what I discussed. Unsupervised classification uses number of classes. Initially you have to define, I need 7 classes. What immediate system will do, will see the minimum, maximum, divide equally by 7, and then it will give you 7 different classes of objects based on the equal individual clusters. So computer will group together, cluster together, spectral characteristics, and depending upon your need, it will classify. The work of us human intervention is comparatively less, but human intervention will be there in unsupervised also. By selecting the tool from the menu bar, and by assigning your number of classes to the system, and after the classification, then we will have to see that what is this color, what is the original color in FCC, what the new color in what is that unsupervised classification. Then you have to assign the name of labeling the features, and evaluate your result. Normally, if the system is doing, normally error will be more. Human intervention, if you give training, automatically it will be less. But here in this case, the probability of error is little high, not more than 20%. But for quick assessment like disaster and all, 5 to 10% deviation, it is not big. Suppose in a flood situation, if you want to assess how much of area is under flood, if you are in position to predict for about 90-95%, it is well and good for the administrator to see the result immediately in no time. So So this technology is highly helpful during such situations. And this unsupervised classification is a pixel based classification. That's what I said, based on number. Your computer is automatically doing. That's what computer automatic classification. Number of classes defined by an individual, a human intervention. So number of classes based on spectral classes automatically will take by looking the attribute table, that is at the backend lookup table. The system will do on its own of classification based on the pixel value of the band individually. And what is the advantage and disadvantage? And as I said, it's very quick, because you don't have a much role to play between you and the image processing software, and it is easy also. You don't need to have any knowledge, prior knowledge of image processing system. And this will purely that based on spectral information, there is amount of reflection which is coming from every object. Maybe in vegetation there are some sectors between 60 and 70, like that it will automatically, people have experienced by using spectroradiometry in the field based on the values of minima maxima in the field. Like paddy culture, they separate, maybe they group together. 3 months paddy culture will have this spectra, 5 months paddy culture this spectra. Now if you have knowledge or the reference of the pixel value, you can ask your system to classify. So it's purely based on spectral information of the experiences of the human being. It's being set at the back end by means of arithmetic calculation, so the system will do. It's do not always corresponding. It will never care about the informal informational classes. No, you are not classifying. You are not giving anything. It is taking, dividing the available digital values and then divide. The user has to spend time for giving the label. Of course, it is true. System doesn't know such. The system will classify the numbers alone. Now we will have to sit and then see the backdrop of the FCC or backdrop of the geology map or topo sheet. Swipe here and there and then find. Spectral properties of classes can also change over time. So you cannot always use the same class information when moving from one image to another image. You cannot expect. It will vary from place to place according to the condition of the terrain. It will vary. Even paddy culture will behave separately in different situations and conditions. So what is the unsupervised classification does? It determines the natural grouping. After grouping based on the spectral similarity, it is being grouped. Features were categorized and analyzed into different classes on their own, and after that you are now roll over below the image and see how the computer might use. It's very simple concept. Grouping together based on what? Based on spectral signature or the numbers. System will do between 63 to 70 is a vegetation. That's all. It will not look that where 63 adjoining to the 63 is what it will not see. Sometimes it may also failure, that you have to check, cross check with respect to accuracy is concerned. This is very simple examples that how unsupervised classification is being done. See, for example, here you are asking, I need my classification of the given area. I want to group it 35. But look at the picture. You have a big class by this color, second big class, third big class. And maybe that these are all very smaller group. Of course, it has similarity. But you see, most of the classes which you can see on the periphery, it is only one color occurs. So normally how that this classification, you see single linkage of Gaussian data at 35 classes, the biggest classes starts fragmentation into smaller parts. Very not even, sometimes individual pixel will be classified as a separate group. And suppose if you are asking for 20 cluster, again you see the grouping, this is a different area. You have noise problem is there. Since linkage clustering does not have a notion on noise, you see this is the noise. At the periphery you can see that this is classified as an individual group. This is classified only one pixel as. So this sort of problem will exist in the unsupervised classification. Sometimes what will happen, it will do very excellent. There are two bands, it is being taken, band X from 0 to 100 and band Y of 0 to 100. You ask, it will classify, it will group together wherever it is possible. This is also it is also happened at some places. So clustering, how clustering is being done, how grouping is done, how classification is done by using unsupervised classification. It is two steps. The operation of clustering algorithm is being done by two steps. First, it will classify in the equal interval. The program reads the data and set sequential bits. It means it will automatically group 10 to 20, 20, 30, 30, 40 like that. Sometimes if a fellow is there, if your value starts at 10, a fellow is there at a value of 2, the system will get confused. Should I want to make it as a separate, or should I group it to 10, it will ask. That is called minimum distance. Distance of the pixel value to the distance of the classification it is, so it will automatically push the particular pixel into nearby group and then form. So that is called second category. So these two steps are there in image processing and unsupervised classification. In past one, what I said, it will automatically classify. So there are 4 steps involved. Now we will have to define what is the radius of. Suppose if I am asking that I need a vegetation, then I have to define what is the radius of vegetation. If I classify vegetation as a paddy culture group and sugarcane is separate group and grass is separate, then I have to define inside between 60 and 70. I have to define 60 and 63 is paddy culture, 63, 70 is sugarcane, and 58, 60 is your grass, like that. First radius of spectral space to determine by the individual. A spectral space distance parameter, there you have a minimum distance rule place, that how its merging happen, and then the number of pixels to be evaluated between each. Number of all these things it is mentioned. There are 4 steps. After 4 steps, you have to go to this level 2, that is pass 2. In pass 2, what the system is doing, it takes nearby information either at the lower end or the higher end or nearby end. So the final, that's what they have given this. Of course, I don't want to read that. It will shift the pixel value into the nearby. Now labeling, it is a manual work. We have to define after classifying. You will get classified image. Probably it is there in the next slide. You can see. So now you have to go through at the back end. You just put backdrop and see. You have to name it of all the things. Identify the location. See your experience, and sometimes your visual scatter plot. Everything you just look at the back side of the graph and then name it. So this is one group of classification in the Kakinada. We have requested our system to give 6 class. It is giving a very excellent 6 class. And you see, you have to do pre-classification processing also here. Then what does it mean? As I said in the earlier slides, that human intervention is less. I didn't say that no. Human intervention is less. So here all the features that you are going for grouping 10 classes. Then I must know what 10 classes will come to my study area. So what the system is doing, system is grouping and say that this is one feature. Sometimes all need not be a single class. That is the first aspect. All aspects of the reflectance is grouped as a feature. The simplest feature, sometimes only 2 pixels or 3 simplest features, not necessarily the best feature. Sometimes this will influence the atmospheric scattering or topographic relief variations will affect the pixel value, and with that we cannot conclude that the pixel has to be categorized in which category. This is another examples of Landsat TTM data, and this is the unsupervised classification. And this is another Landsat data, and of course the year of the data and all given. So system is giving no time. And even you see that this is one Landsat MSS digital color infrared data, and the spatial resolution of 57 meter. Classification is done it in no time. And the Corona, this is panchromatic black and white film acquired in 1969, spatial resolution 3 meters, and it is classified. So now what I would like to stress upon here, unsupervised application has got a lot of interest, where the situation force administrator to take up quick action, like flood, like earthquake, like landslides, any natural hazards. If they want to take a quick decision, so this is helping. And sometimes this is helping for a learner to start the research in the first stage, how classification is done by using satellite data. With this unsupervised classification, discussion has come to an end. Thank you.